phones on silent, please. Tony Dean is going to be speaking next. And I tell you what, he was with us for an event last year, and he was actually doing installs in my shop the day before. And I told him, you got the toughest gig tomorrow because you're right after lunch. And he said, not a problem. And I said, okay, whatever. Because if you talk to Tony and he's not excited about something, he's a good old boy. Now that being said, he did just say pecan and not pecans. Don't let the accent fool you.
No, I'm sorry, but there's a reason. Because one's a pecan and the other's a pecan. Just saying. If you ever needed to know the difference, that came from Oklahoma.
Tony Dean, ladies and gentlemen.
Hi, folks. Well, thank you. My name's Tony. Y'all heard that. Here's what I hope. That this is kind of different than what you've seen before. Has anybody been to my seminar before? Okay, so this is like the after lunch crowd, which means that y'all have a tendency to want to sleep, right? Can I use y'all here? Y'all? Okay, everybody got that one? Is you all, yous, yuns? Did I catch it all? You guys? That's Ohio. You guys? Here's the deal. I don't think you're going to want to sleep as long as you do what I'm getting ready to ask you, and that is participate. Because I ask questions. Now, y'all go get the answers correct every time? You'll try your best, but no. And ain't no harm, no foul in that, because what we're doing is we're dialoguing, and we get the answer out. So the first question comes, what the heck is back to basics? Right? I was told come talk about back to basics. Right? Didn't he already talk about back to basics this morning? Y'all can nod your heads like this because that was exactly what happened. All right, so what do you think I'm going to be talking about? Back to basics. Psst, it's the big letters. What do you want from this segment? Get better at finding leaks. Okay? We can do that. Okay? Usually back to basics means we kind of talk about why we do it. But do you have leak detectors that have dipole antennas? Do you know what I mean by dipole? It's got two, right? Here's how you get better at finding leaks with a dipole antenna. See, I'm going to try to give you what you asked for, right? Do y'all have the one that looks like a gun? Or do you have one that's on a stick? So you got the one that looks like a gun. Do you come out like James Bond, looking at it like that most of the time? That is a problem because leaks come out at a polarity, okay? What that means is that, for example, if you have a hardline crack, right? Then think about it. The crack is horizontal. Your antennas are going to best pick it up if it's horizontal, right? Radial crack. What do you think that one is? Right? Vertical. Here is a stupid question that I ask. Yes, I said stupid. It has a stupid answer. But it demonstrates, hopefully, the point that I'm trying to get. So, I want answers. What is the polarity of a squirrel chew? Zigzag's a good answer. It's probably the best answer I've ever gotten to that question. Zigzag. Anybody else? Think about it this way. Here's your line. It depends upon the angle of his little itty-bitty head, right? Whatever angle her head is, his head is, that is probably the polarity, unless they got jagged teeth, like me. If they got jagged teeth, right, then they could have polarity bouncing out at any point. So my point to you is that when you have antenna that is horizontal, which you normally do when you come out of the vehicle, right? Sometimes you need to check to see what the polarity is. Is it a radial crack? Is it a horizontal crack? Is it a squirrel chew? Right? And find what it is. Now, the beauty of a dipole antenna for these things that you have, right, is if I move 90 degrees away from whatever the dipole antenna is, so if I'm facing, and the back door there is my leak, if I move 90 degrees away from that leak, I null that leak out. Does that make sense to you? So as I sweep around, leak gets bigger, 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 softer, 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 bigger, 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 right? So that makes sense, right? Null it, full. Well, if it's a vertical crack, then it's going to be this way, right? So it's going to be louder, softer. Do you get it? Quick way to remember it. Whichever way your antenna is pointing, not the gun, the antenna, whichever direction the antenna is pointing, either that way or that way, either that way or that way, is where the null point is. It's the minimum. So, to bring you to a point, when you drive down the freeway, when you drive down the roadway, when you drive down the street, who found the leak? Who found the leak? The computer. Where'd that come from? One of the trucks, right? So one of the bucket trucks has driven around and they found a leak. What polarity is their antenna? And if you get out horizontal looking for that leak, and the antenna found it at its maximum potential vertically in this position, you have just nulled that leak out if you never moved for polarity. Does that make sense? Excellent. Point number 2. See, we haven't even got, by the way, I've got like 50 slides, so just to let you know, all right? So you can keep track of where we are. Now, this one doesn't have the number on it. We're going to call this slide number 10. This is slide 1 because we're already working. Here's something I want you to know. The FCC has us do leakage, and they have us do leakage, and when you go to find a leak, they ask you to come out 10 feet and down 10 feet if it was a pole leak. Did I make sense with that? Right? Come out 10 feet, come down 10 feet. It's a 3-meter diagonal. There are 2 reasons, and they want you to do a horizontal dipole antenna. There are 2 reasons they do that. Number 1, if you're doing it with a horizontal dipole antenna, you can duplicate their found leak or they can duplicate your found leak. Does that make sense? Okay? The other thing is the reason they come out 10 feet is because in this space here, this first 10 feet, you lose 22 dB of signal. Are you with me? After that, every time you double the distance, you only lose 6 dB. So it's 22, 6, 6, 6, 6, 6, 6, 6, 6, 6, all the way out. All the way back, it is 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 22. Mean anything? Here's where it really gets good. Every 6 dB, you either lose half the signal if you're going that direction, away from the leak, or you gain half the direction. Did you hear what I said? Not signal. Half the direction. Also, half the signal. So here's the way this works. First 10 feet. I call that no man's land. The reason is you should never take a reading in there. You can go hunt for a leak in there, but don't take a reading there. Then after that, I'm at 10 feet. And every time I double the distance, I lose half the signal. So I go to 20 feet. I have cut the distance in half, and I've lost half the signal. 40 feet, half and half. 80 feet, half and half. 160 feet, half and half. Going towards the leak, it's the same thing. If I'm at 180 feet and I go to 90, what have I just done? I've doubled the signal. What else have I done? What did I do with the distance? I cut the distance in half. Here is a troubleshooting tool, which was not part of this seminar at all. It's part of some, but not part of this one, that I hope you can use forever and ever and ever. If I know nothing more than what the signal is reading, and for these purposes, we're going to assume a horizontal dipole antenna, and all the circumstances are perfect. So there's no strand travels, no reflections, no blocks, no nothing. Everything's perfect, right? And I'm reading, give me a number.
200.
I'm reading 200. And we said it's horizontal. And I walk, right? And I'm walking in the appropriate direction to find my leak, which is the hallway. And my 200 reads 400. What have I just learned? I'm halfway there, which means not only am I heading the right direction, but however far that I just came, I'm just saying it a different way. However far I just came is the probable location of the leak. Because I doubled. So knowing nothing else except for the polarity, if it were crooked and I'd do it like this, notice I did not say crooked. I could. But if I did this walking toward the leak and my signal doubled, I should be approximately half the distance in the 10-foot mode on your leak detector. 10 feet is 1-to-1. Why do you have distance settings on your leakage detectors? Yes. My answer would be because y'all lazy. But I'll take y'all's answer. That's all right.
Trucks can't go in backyards?
That's a really good answer, because trucks can't go in backyards, right? Your distance settings, and this is the last thing I'm going to do, and then I'm going to go into the presentation, and we got 50 slides to get through in 40 minutes. That's going to be quick. You have distance settings on your vehicle to approximate what a leak would be if you were standing next to it over there, but you ain't got out of the truck yet. Does that make sense? Here's where it gets really brilliant. These are just easements in the plant. 10 feet is 1-to-1. It's that FCC leak, right? 30 feet would be a front pedestal. 75 feet would be halfway through the house in a normal setup. 150 feet would be back pedestal. Does that make sense? 10 feet is 1-to-1. That's always your home base. 30 feet is 3 times. 75 feet is 7.5 times. 150 feet is 15 times the 10-foot reading. So if I'm in the truck, I'm in the vehicle, and I'm in the 10-foot mode, and my leak detector says 10, how much is the leakage reading if it's coming from the back pedestal? It's 150, so I go to the back pedestal, I'm over to the back pedestal, and 10 foot, horizontal dipole, it's 150 microvolts per meter. It allows you to guess, if you're having a low brain moment, of what the leak would be. Here's where it gets really simple for you. 10 feet, 20 feet, 30 feet, 40 feet, 50 feet, 60 feet is 1 times, 2 times, 3 times, 4 times, 5 times, 6 times, keep taking it out as far as you need to, the 10-foot reading. How close is to you in a vehicle on the curb is a back pedestal fed signal? Before you say 150 feet, is that where your plant is? It depends. Where is your plant? If you're at the curb and the signal, the tap is being fed from the back easement. Where is the closest approach to you where you are?
The house.
The house, okay. What did I say about the house? 75 is what?
Halfway.
Is halfway the middle of the house, right? So is that the closest approach of the plant to you in the vehicle by the curb?
Yeah.
No. Where's the closest approach? Where's the closest possible approach? Front of the house, right? If they're feeding the living room or the dining or whatever's at the front, then the closest approach to the house is the front of the house. Yes? You're sitting there with 10 microvolts per meter in your vehicle, right? And you're reading a 10. What's the minimum signal you could have? No, because it's being fed by the back easement. And the front of the house is the closest approach. It is depending upon how front the house is. All right, how close is the front of the house? Pick one. 60 feet, okay? So if I'm sitting in the vehicle, all things being equal, and I'm reading a 10 in the 10-foot mode, my minimum leak is 60 microvolts per meter. Is that significant? It's halfway to a 24-hour repair. It is significant. So you could be in the 10-foot mode, look down at your meter, look how close the vehicle is, and go, you know what? We got a problem here. Because you know that there's no front line. You know there's no front pedestal. The closest approach to the house is approximately the minimum amount of leakage you could have in the 10-foot mode as it corresponds to distance. Did I hook you up?
Yeah, good.
Did you learn anything new?
A lot of stuff there.
Did you learn something new?
Yeah.
Show of hands, who learned something new? Thank you.
Call it day.
I can just call it, right? Because my whole goal was back to basics. That's what we just did. Got to turn it on because I turned it off so we wouldn't automatically do it. Deep thoughts. How many people are old enough to remember that Saturday Night Live had a thing? It was called Deep Thoughts by Jack Handy. Well, I'm not Jack Handy. But these should be deep thoughts. At least I hope they are. So, wow. That was interesting. What is the number one criteria? Number one, that allows us to be in business that doesn't apply to most other businesses. So what I just told you is I just erased customer service, customer satisfaction. Bam. Nice answer, man. Do you know how long I have to work for that answer? No, I'm not kidding you. I have waited for 15 minutes to get somebody to give that answer. You're a closed system, which means that if we're talking about leakage and ingress, and you're a closed system, whenever you have leakage or ingress, whose fault is it? Why? You're sharing it with them. What else are they doing? They're sharing them with you, right? So it's a double-edged sword, and you're getting cut on both sides of that. What are two physical criteria required for us to be able to measure ingress? No, a signal level meter is not the answer that I'm looking for here. You're on to something, though. Not necessarily have a tagger. So let me put this question a little differently. Any service techs in here? Anybody ever was a service tech in the last 5 years? And when you were a service tech, what was the first thing you had to do when you went on site?
Put a cone out.
Okay, fair enough. And then, what's the topic of the question? What's that? Well, fair enough, except I don't think you're shooting anything, right? You're sampling the house for ingress, right? So what is ingress? Absolutely. So there's this dude named P.T. Barnum. Anybody ever hear the name? He liked that word egress, right? and he had a tent, and he had a problem. And on the tent, the problem was written, "Come see the great egress." What was his problem? People wouldn't leave. So what did they find when they went out the tent door? Outside. Ingress coming in, egress going out. Two physical criteria for us to be able to measure ingress are have a signal source. That's why I said you were close, but when you start talking taggers, we're not there, right? Have a signal source and have a hole, right? You got to have a big old gaping hole, and you have to have ingress. Here's why I mention this. If the first thing that you're required to do is to go on site and take an ingress test, right? And your techs hook it up, you've sent them there. Why have you sent them there? Because y'all got too much work, and they're trying to help y'all out, right? And they do their ingress test, and they got nothing. What is their normal assumption? That there's no problem, that there's no ingress in this house. Is that true? Why? There can be a leak, but they haven't found it yet because they're at the tap. No signal source. An example that I like to give, and like 98% of this is not true, okay? Friday, Saturday night at my house is Margaritaville. It means people come to my house and have margaritas. Not true. In my kitchen, which is at the back of the house, not true, is a TV underneath the cabinet. Also not true. Which has a cable signal supplied by, true, and it's hooked to the TV via a coax. Where'd they get the coax? You would like to think so, but where I come from, there is no Radio Shack. Amazon is probably the correct answer now. The most common answer that I've been getting the last several years is the dollar store. What are the odds that it's a push-on connector? Is that thing open fairly easily? If the customer installed it, and if it's a TV underneath the cabinet at the back, then they probably installed it. Did they wrench tighten anything? Right? So in this artificial circumstance, it's Friday, it's like 5:30. We're making margaritas with my blender, which is one of them super blenders, Vitamix, true, directly underneath the TV. Do we have a problem? What's the problem?
Your blender's under the cabinet.
But why is that a problem?
Because you can't fill it to the top. You got to fill it.
That is true. So my blender is actually out a foot, but not off of the cabinet, but it's near the TV. What's the problem?
Because of the signal. The signal the motor's putting out is getting picked up.
That's it. It's actually not the plug-in as much as it's the brushes, right? Those magnetic brushes going across and touching each other make broadband noise, which happens to just creep right into your cable plant and does what? Creates a source of ingress and also does what? What does ingress do to your plant? And?
Makes me have to go out and find it
And?
and not have a margarita come working.
And?
That's all I got. Service calls?
Do we do anything to the return path when we have ingress? Sure, we trash, especially if it's broadband like that signal is, right? So who's affected? Not quite everybody, but the node is definitely affected, and whatever this node is connected to, so through the back. So you've got a fair amount of people that for at least an hour, because we really juice these margaritas up with 151. What is it? 151. Have y'all seen 151 Cuervo? Yeah, they started making that stuff. That is crazy. So you got 151 Cuervo or 150 or something. It's spicy. And everybody for about an hour is good to go, and then what happens? Everybody's passed out on the floor. right? Who's on call? Who's on call? You're on call, right? So you got all of these calls because you came into, by the way, we're on slide number 2. You got all these calls. You got all these calls coming in from your neighbors. Why?
Because they weren't invited.
They were, but not everybody in the node. But you're getting these calls from some of your neighbors which weren't invited. And why? Because their internet's not working. Maybe their phone's not working, right? There's a serious amount of calls coming in, and you're dispatched. How soon after the first call are you dispatched? That's the answer. By the time he gets there, is he going to detect a leak from the road at the back of the house, which is how far away? 75 is the middle. I'm probably like 90 or 100 feet back, right? So if I walk this way and it multiplies by 10 per 10 feet, what happens the other way? I've lost 90% maybe of the signal. I've lost a lot of signal, right? Is that little tiny leak going to get all the way out to the vehicle? Now go get to your vehicle. So what are you going to do? Do you even have a house? No, so you're still trying to locate this problem, right? You're cruising through, nothing happens, right? It happens again on Saturday. You're still on call. Did you think to prepare for this? No, because it's the second time, right? After this happens for a couple of weekends, y'all have got your heads together, and we need to try to locate this down. You take a strike team. Y'all have strike team, right? What do you call it? SWAT team? Y'all got the SWAT team, right? Eventually, you know it's this node. Go fix the node, right? Ultimately, hopefully, somebody has found this problem. All to get back to the problem that you need 2 things, 2 physical criteria. There must be a hole. There must be a signal source. I can provide the signal source, but when you come to test it, you got to know where I am before you find that problem. Make sense? Historically, what 2 businesses have made us focus on leakage? LTE would be one. What's the other? Air traffic, airplanes. Aviation and cellular technologies. Let's expand on this one for a moment. I don't know about y'all, but this has always fascinated me. I actually have recently found more material, but this is still in the abbreviated form. Aviation, back in 1976, how long has cable been in business? Since the 50s. And it took all the way to 1976 before we had our first observed interference with airplanes. What does that mean? We've been interfering with a while. Has it been observed before 1976? But they didn't know what it was doing. And then an airplane came to land in Harrisburg, and it was interfered. The communications were interfered with, right? So what'd they do? Abort, right? Because they need to be guided in. And they went to a different frequency. Probably, I don't know if you've ever listened to airplanes. They got like all kinds of handoffs, right? If you're pulling away from the gate, you hand off to runway control. From one-way control, you hand off to departures. From departures, you hand off to what the heck ever the next level is, and then you get to 30, 40, 50,000 feet, and you hand off there, and you go a ways, and then you reverse the thing, right? They probably went back to the last frequency and said, we got a problem, right? Well, it was observed that it was us that caused the problem. In 1978, an advisory committee was formed. Our chief engineer, who's actually only retiring this year, along with many other people, you probably know some of their names, and FCC, FAA, NTIA, cable TV reps, and other groups that were aviation interested. Out of this list, is there anything you don't get? Yeah, me too. NTIA is the National Telecommunication and Information Administration. Believe it or not, it's still in play. It's an agency that advises the presidents. Okay? So even the president had representatives at this meeting. Who was the president in 76? So President Carter was being advised, sir, we have a problem. Meanwhile, in 78, we had the second and third documented case. In 79, the fourth, and also the FCC adopted the rules that carried through until when? Last spring. When it was analog only, analog only, analog only. When did y'all turn digital? Before last spring. So it finally, we were under these rules in 79 all the way up until last spring. I think it was like March, April, May. I got the date on my wall to when they officially said, you've got to adhere to this standard. Meanwhile, in April of 81, the FCC began to fine. So it took them 2 years to get everybody comfortable with where they were. Were they comfortable? Now, are we comfortable now? Right? In 82, the FAA requested assistance. So we're already fining people, right? The FAA required assistance to investigate the source of interference with the ILS. You know what the ILS is? Isn't that that pointed upward dish that you see at some airports? I think it is. I think that's what it is. Anyway, it's funny, when the local cable system was asked, was that y'all doing that? All of a sudden, before anybody could investigate it, the problem went away. Nobody fessed up. Anyway, the next thing is cellular technologies. And with cellular technologies, between 2010 and 2012, about the same time we started going digital, we also started hearing an uptick in complaints from the LTE folks. That is just intriguing. Okay, so we're back where we left off. What would be a third reason that we're focusing harder on leakage? We already talked about this. We talked about this a lot. Ingress, right? When you're talking about LTE, we're messing with them. When you're talking about aviation, we're messing with them. So what ended up happening is, right around 79, we get some rules together, right? And then they start enforcing them like really heavy. How much time? I don't remember when we started.
Like 110. Well, you got 35 minutes.
35? Okay, excellent. We got page 4. In 1979, we started developing, and 81, 82, we started fining, right? FCC, are they applying at that time? Are they applying? They created rules. They distributed rules. They started fining people for rules. They start finding stuff according to protocol. Are they operating at full capacity? Why? Because they got new rules. They got new stuff, right? They're sitting there. Cable systems are getting fined. Does anybody remember the dry period where you never even heard of the FCC? Anybody? There was a period there where if you heard of anybody having the FCC visit for any time, they hadn't seen the FCC in 5, 6, 7, 8, 9, 10 years. They hadn't seen them. But then we started paying attention to our leakage programs because of... Nope. Ingress. And now today, even more importantly, because ingress absolutely kills our digital signals. It was already killing the return path as it was, right? But we started focusing more on leakage, so call it self-policing, because of ingress. Why would that be? Because when there's ingress, you're messing with my money if I'm Comcast, right? If LTE interferes with your signal, does it cost y'all money? Yep. Well, of course it does, right? That's why you started focusing. So before it was fear of fines, now it's fear of income loss, right? And that worked really good. And then we got digital, and then we got more focus from the airplane people. What are some of the things you currently employ that assist in the elimination of both ingress, which is RF entering, and egress, RF escaping our cable plants? What do you do now? What's the tricks of the trade? Path track, leakage gear in the trucks, strike team, was it? SWAT team? SWAT team's really good for doing that. I think the first SWAT team I rode with, the first team of that type, was right here in this town. It's a couple years back, but I was quite impressed. One of the things we found, we used the pressure testers, right? And we went in and we found so many things, it was crazy. The things that we found were, there's 2 drops coming into the house. One of them terminates at the ground block, right? The other keeps cruising on through into the house. We can't tell which one is leaking from us pumping signal in, so we replace 2 drops and install a ground block. Okay? This problem goes away. Problem immediately begins at the front of the house, which we could not get into at the time. So we were grateful to solve that problem. So there's a whole bunch of us on this thing, right? And I'm standing out on the sidewalk. And the front of the house is literally farther than the back wall for me. And this is a big room, right? And I'm sitting there with a leak detector, and I don't care what polarity it was at 1999, which meant what? It was maxed out. So how big was the signal? Greater than 1999. And the fact that I could sit here and do the meter all different ways and it didn't change, and more. So I just sat there, because we didn't want to freak out the people. They'd never been able to get into this place. They knew of this place, right? All of a sudden, boom, my signal goes down to something manageable, like 200 or 300. Boom, it goes away. When they come out, here's what they tell me. There is a 16-port unity gain amp in the house with 15 ports open. I had actually carried a crud load of terminators, 75 ohm terminators. They had most of them, and they used them all on 15 ports, that unity gain amp, which left a leak. Then they went over to the back of the TV, and on the wall, not on the TV, on the wall, it was loose, like barely on. They turned it on, put a 7/16 wrench on it, problem went away. That's the value of a pressure tester. So a pressure tester provides you with a qualified signal, kind of like your tagging device, like at least for ours. The tagging device you have in the head end is the same thing with a different code on it that you put in your hand. What's the downside of a pressure tester?
Take the service down, right?
You got to take the service down. That would be one. What direction does it go? And what way is that? It would go literally from the tap to the house or the ground block to the house. So you can't use it on the trunk. How many of y'all work in the trunk? That's why we're not going to spend a whole lot of time talking more about those things, because y'all wouldn't use them. But your counterparts, the service techs, whoever is good enough to go after it, do you know what I'm saying? Right? The go-getters, the lead techs, those guys need a pressure tester. Almost all of us in the manufacturing side build pressure testers. Okay? Y'all have leak detectors that are compatible with somebody's, right? Those guys could use them right now and only go for the cost of the black box. Here's a nod to you, Jason. The return on investment is under a week for this device, for the people who work in the drop. Here's how that works. If I reduce one truck roll per day, how much money did I save? $150, okay? Multiply that by 7, and you have several $100s to spare that black box emptied. And your speaker this morning was absolutely correct. You hook this thing to the house, and you don't find what the problem is, you are not looking. Okay? We're done with that. And that was the next question. Pressure testing? It's an excellent method to add to any leakage program. What method can we employ as an industry to immediately reduce leakage from our cable TV plants? Right, we're going back to basics, right? Back to basics. This is a back to basics question.
Don't leave hot drops.
Fair, not the one. Positive application of a 7/16 wrench. Yes, I know you use torque wrenches, right? But positive application of a 7/16 wrench. But wait a second. Do you notice it says old school up here? Why do you think it says old school? Huh?
Because the new guys don't do it.
That's fair. I could spend an hour on just that alone. Why do you think it's old school? What's that? No, it's Titan fittings. It is more than Titan fittings, but in this point, it's Titan and fittings. Because in 2010 to 2012, whose job got harder? No, the guys who were working in the drop, their job pretty much didn't change. Y'all's did, right? Housing to housing, power inserters, right? The dogs that are on the various amplifiers and or taps that you use. How many wrenches are that? There's a whole bunch of them, right? New school is channel locks. Yeah, if you gotta. New school is any. See, my slides are not this messed up. It's the connection, and I'll stand by that. Any wrench. Any wrench. Woo! Leakage problem areas. What are some of the common leakage problem areas? Obviously, we talked about one. What do y'all encounter? Squirrel chews. What was the other? Radial cracks. What is it? Customer installs. A whole bunch of things. Drop fittings. Right? I have been sitting in an SCTE event where they reteach you how to make fittings. Anybody ever experienced that? Y'all serious? The guy who makes the cables and the connectors comes in and gives you a test on whether you can do that or not.
The PPC guy. Yeah.
The PPC guy. Have you ever seen anybody fail? I was standing beside a supervisor who was being cocky, right? He got burned for a stinger that long, right? This is the guy who is teaching others normally to do this, right? Is it possible we got bad drop fittings? At least under that scenario. Poor construction? By whom? It's always the contractors. Believe it or not, if we were, what's that game where they guess them? Huh? What's the game where they guess and they flip the thing over and the number one answer is? Family Feud. Contractors is the number one answer. Unless you're a contractor. Who? Could be you. Definitely that supervisor, right? Customer and themselves. Screw-on fittings, right? Those are just nasty things. Customer self-installs. Staples in the coax. What? Does that apply? Here? There's a reason this is on here, because in New York City, they still use the staple gun. There's two problems, and this is their number one answer. There's two problems with it. The obvious one is you stapled in and clipped the shielding. Okay? What's the other one? Impedance. Hit it too hard, change the impedance, right? Staples in the coax. And of course we mentioned animal chewage, right? So here's a question. Y'all had enough of the deep thoughts? Your brain tired yet? Anybody fall asleep on me yet? So wait a second. You didn't fall asleep after lunch, and you learned something new. That's pretty cool. So I'm going to reward you. This is Miss Pearl. It's a picture of a large squirrel. I took that picture. Ms. Pearl lives about, 15, 20 minutes outside of Austin, Texas. What is in Ms. Pearl's hand? Think carefully.
Pecan.
Right? Where do you think I was when I got corrected? I was near Austin, Texas. Ms. Pearl is purportedly the largest representation of squirrel anywhere in the world, that, at the best that they know. Stands outside of a pecan shop. But to tell you that they do things in Texas different is just craziness. Are you ready for this? When they're closed at the pecan shop, right, they have a vending machine out front to dispense. You'd think, wouldn't you? Pecan pies. Full 12-inch pecan pies. You put your credit card in, ka-chunk. Hopefully it ain't broke. Right? And you can get a pecan pie. That's Ms. Pearl's claim to fame. But yes, you got to love it. They like to do things bigger. There's 2 examples, and that's one location. Ms. Pearl is 14 feet tall. About 2 or 3 years ago, do y'all remember that there was a movie that came out sort of like this? These guys interviewed for the job. That is a squirrel chewed hardline. Is that real? Y'all see that quite often? This is what that would look like if it were a water carrier. That is what leakage does. What's the polarity of that leakage?
Zigzag.
It is zigzag. It is everywhere. We had a video, but instead, I got this. Do you have any questions? This was the intro material.
What?
Oh, yeah. We're on page like what? 8, 9? Something like that? And roughly in my head, I think we have 24 minutes. 19? Dang, I went long. All right. This is an analog signal. Everybody understand what that looks like? Why do you think I'd be talking to you about analog signal? Is there anyone who's still trying to use one of the old analog receivers to try to find leakage today? Probably not, because y'all spend an awful lot of money on digital receivers. But here's why you don't want to do that, and here's why for several years that did not work for you. Because this is what a digital signal looks like. Come on now, you can do this. That's what a digital signal looks like. Remember hearing this morning, it's measured over a 6 megahertz band, whereas before, the analog signal was measured in a 25 to 35 kilohertz resolution bandwidth. Really narrow. All the power of the analog signal's here. All the power of a digital signal is across the entire 6 megahertz. Here's why you could not get a reading that was worth anything on your new digital signals using your old analog equipment. Was it green, your old equipment? And then it turned blue. It had to turn blue because you were taking a 25 kilohertz slice, the width of an analog signal, right, of a 6 megahertz signal. You had 1/240th of the signal strength. But wait, there's more. Y'all seen that tape where they tape up the boat and then... You carry digital signals lower than you do analog signals by 5 to 6 dB. So 6, the bigger number, is actually not the least. 5 is. Yes? So in best case scenario, your digital power 5 dB below where you would look for an analog signal is 1/759th of the channel power. It's a 1 to 1,000 ratio, which is why you couldn't find a leak. It looked like noise. How many of you have heard that way back, this was probably almost 10 years ago by now, almost, that when we go to digital leakage, we won't have to do leakage anymore because, you heard that? Well, there were no rules. Yes, Jason?
I heard it.
He heard it. Anybody else? Because when you take 1/759th of the channel power, what does that signal look like on your meter? It looks like nothing. So it was extrapolated that we won't have any power to look at. Our leakage won't affect anybody. And it'll look like the noise floor. And then what happened? No, not yet. LTE. Those guys started knocking on y'all's door. Anybody familiar with the process? You've done it. Anybody else? These guys came in. They would give you a map of the location. They would give you a leakage value. They'd give you all kinds of information for you to go help them find the problem. You didn't have digital guns yet, right? So you go out and you go with your leak detector and you go to find the signal. Is it there? You darn right it's there. But you're not finding anything. Here's what complicates matters even more. Okay? 80% of the time, you can have a leakage reading either in the aeronautical band or the LTE band and not the other. You hearing me? So normally, with a digital leak detector, you will find a leak either at one or the other frequency, but not both. And then you were going out there with the green guns and looking at 1/170/59th of a signal that you couldn't read anyway. How many of those signals did you find? What percentage of the time? You found 0 of those 100% of the time. That comes into play in a minute. So, questions about analog digital signals? We've got 15 minutes left, and we are on 18. Here we go. This is what we monitor simplified. Why do I say what we monitor simplified? Because that's up to 1 gig, and you don't even put signal out there, but that's what we would hopefully monitor eventually. And what do you see that stands out?
Red.
The red, which is? What that mean? It's the aeronautical band, right? They started complaining in 70, they started fixing things in 79. We had to start dealing with them. And until 2010 to 2012, we did not have to deal with those guys. How long have there been cell phones? I can tell you that 25 years ago, we had a van outfitted with a bag phone. That was a cell phone. That was 92-ish, 93-ish when I did it. And I know they existed before that. And they were even bigger, right? So, why 2010 and 2012? 2010 through 2012. By the way, any of y'all know the name Ron Hranick? Ron Hranick is like one of the smartest people in our industry. He now works for Cisco. We've actually worked with him on some of our equipment profiles, even currently. Ron, I caught him spring last year at one of these events, and I was like, okay, Ron, I'm getting ready to ask you a dumb question. I'm open for the ridicule, but I was told that 2010, 2012 was when we started figuring out that LTE was the problem. About when was it? 2010 to 2012. So even some of the brightest minds in our industry had no idea that when you have a big old gaping hole, that it didn't necessarily mean that you could find the leak. So why did we have to worry about them in 2010 through 2012 when they've been doing this forever?
You weren't using over 800 megahertz.
Nope.
Because we weren't broadcasting up that high.
Nope.
It's something to do with 4G and LTE instead of 3G?
Digital?
More money?
How many have heard this? Whenever you want to find the cause or the beginning of something, where's the first place you look? You follow the money, right? I'll show you later what that looks like. But effectively, wow, the reason this is becoming a problem for us now from 2010 through 2012 on is that the LTE business, the cell phone business, started making money. So they invested in $50,000 spectrum analyzers with leakage modules on them, and they started noting something. What was that?
We have a lot of leaks.
Y'all had leaks. So they come to you with this dilemma, right? So now they come to you with the dilemma. They tell you where it is, what it is, how it is. You go out there with your analog leak detector and how many percent of the time? 100. Now, they know that they know that they know that it's you, and I'll show you why in a little bit. But you're basically saying, no, I didn't. Worse, some people took that piece of paper and filed it where they thought was appropriate. That's not good. You get a bad relationship with those guys, they can mess y'all up. How can they do that? Absolutely. Good answer, quick answer. I never get that answer that quick. Think about this. They've handed you a piece of paper telling you that they know that they know that they know that there's a problem here. And you are rude and inconsiderate to them. If they can't get results out of you, they've got to go somewhere, right? If they're coming to you and me, we have a good relationship with them until we don't. When we have a bad relationship with them, they go to the governing body. How many of y'all think the FCC is a bunch of bad guys? Some people do. Let me offer you this. FCC is charged with making the rules and enforcing the rules. All right? If they come to you, what rule is getting enforced? If the LTE guy comes to you, what rule is getting enforced? None. If they go to the FCC, what is their responsibility? To enforce the rules, right? Up to and including? Actually, that's up to. What's including? Shut you down. All of it, right? Not necessarily. Not necessarily. Whatever is being affected. But we have a rule. Here's the money. I'll show you in a little bit. Here is the FCC rule. This was the old rule. This is also the new rule. There were a lot of companies that said, I'll update my leakage equipment to digital when the FCC changes the rules. When was that? Last spring. Thank you for listening. Right? Last spring. So there'd have been some people 2010 through 2012 through last spring would have seriously and could have seriously had some serious issues with the FCC because here was also included in the rules, and this is what the FCC has to say. And I'm going to tell you this right now. The answer to the question I'm about to ask you is not the FCC. Because this is what the FCC had to say about this. They said that harmful interference is any radiation that endangers the functioning of a radio communication service. They said that any operator that causes harmful interference shall promptly eliminate it. If the interference is harmful to communications involving the safety of life or property protection and cannot be promptly eliminated, the offending operation shall be suspended, and then D says you'll document all that. All right? Here's the first question. Who decides what is considered harmful interference? I told you the FCC is not the answer, dude. Come on. Was you messing with me, or was that a real answer? That That is a correct answer. That is the correct answer. I would offer to you that the person being harmed, right, determines what harmful interference is. Because remember what I said. The FCC said what they had to say about harmful interference. Do you notice it's wide open for interpretation? So when you call tech support and ask Comsonics what the deal is and what's considered harmful interference, what are you going to hear? You're going to hear that harmful interference is any radiation in danger of the... You're not going to hear any more, right? Because the interpretation is based on who's offended, right? Notice that this one says promptly is one of the words. Who determines what promptly is? I would offer to you that the offended party is the correct answer, right? But that depends on your relationship. Let me give you two examples of what promptly looks like. In Florida, the FCC lives over in Tampa. They go across the coast. They pop into the local operator that operates in NASA, near the Air Force Base, near the airport. It's not a situation you want to be in, right? I'm not kidding you. FCC dude comes in, finds 4 or 5 leaks, writes them on notebook paper. What's notebook paper? It's this stuff. So it's not official write-up. It's not, right? It's this stuff. He goes in to the supervisor, says, I found these. Supervisor says, I'll take care of this. Okay? Then they break out the good coffee beans from behind the bad ones that the techs, and they make a good pot of coffee. They sit there and talk about their moles that got lanced on their nose and their arm and the top of their head. They live in Florida. What can I say, right? I'm not kidding. Every time I've been there, we've gotten the whole dissertation on what got removed in the last year or two. Seriously. Anyway, what you have then is you have a circumstance where good relationship or bad relationship? I'd say pretty darn good, right? Now, up in the crook or the elbow of the state, there was a mom and pop system. They were on one of those barrier islands. For whatever reason, they did not have to report, I guess, and maybe they got large enough that they did. I don't know what the circumstance was. Well, all of a sudden, they got notification by the FCC. You have got X amount of time to deal with this. We actually worked up a spreadsheet, and on that spreadsheet, we took and calculated their CLI on paper, roving, every time. Now, somebody else did this because I'm not that smart, right? But we would plug in the numbers. They had till Friday to fix this, okay? Or they were going to get shut down. So Friday at like 11:30, they got the last leak fixed. What do you think happened? They got shut down because they said by Friday. They did not say through the end of Friday. And that company got shut down. They'd already been fined. They were going through full shutdown because they had a relationship. All depends on this right here. See up in the upper right-hand corner. Who do you think the public safety broadband and narrowband is? Police, fire, rescue. I also call them the ABCs. CIA, FBI, NSA, ATF. Everybody, right? Well, do you remember C? Harmful interference, life, property. If you're interfering with the cell phone company, are you interfering here? Yep. Absolutely. It's even worse. If you're interfering with the cell phone company, you're interfering with this. And if they can't get my heart monitor to the hospital, if they can't get my 911 call when I'm having a stroke or having a heart attack, and they find out it was you, what happens if they